So, example 41 says, sketch the graph of y is equal to 4x cubed minus 15x squared plus 12x minus 8. So, the first thing, let's identify what's the y-intercept. Now, once a polynomial is written like this, where y is the subject, the number at the end is the y-intercept. So the number at the end is minus 8. So it means that this graph will cut the y-axis at minus 8. Remember, the y-axis is the line x is equal to 0. So when x is equal to 0, every term in the polynomial that has x in it is going to come out to be 0. And that is going to leave the constant term, which is minus 8. So I can say that 0 minus 8 is the y-intercept. All right, now the next thing I can do is I can try to identify the turning points. So to identify the turning points, I need to find the first derivative. So I have, let's go straight ahead, dy by dx is equal to 12x squared minus 30x plus 12. All right, and the reason I have to find dy by dx is because at maximum, or at the maximum and minimum turning points, dy by dx is equal to 0. So therefore 12x squared minus 30x plus 12 is equal to 0. 6 is common, so let's factor out a 6. So we have 6 into 2x squared minus 5x plus 2 is equal to 0. 6 is not 0, so therefore it must be that 2x squared minus 5x plus 2 is equal to 0. Let's factorize this. So if we factorize this, we have 2x here, x here, 2 here, 1 here. Both are negative. All right, and so it is either 2x minus 1 that is equal to 0, or x minus 2 that is equal to 0. So therefore x is equal to a half, or x is equal to 2. So those are the values of x at the turning point. So now that I have the values of x at the turning point, let's determine the value of y, the y value. So I'm going to say when x is equal to a half, y would be equal to 4 times a half cubed. Simply replace x with a half in the polynomial, minus 15 a half square plus 12 times a half minus 8. All right, so all you have to do is just put that in a calculator and press equal. And if you do, you're going to get y is equal to minus 21 over 4, or minus 5 and a quarter. So a half minus 5 and a quarter, or a half minus 21 over 4 is a turning point. All right, let's identify the next turning point. I'm going to say when x is equal to 2, because the values of x at the turning point is x is equal to a half and x is equal to 2. I'm going to say y is equal to 4 times 2 to the third minus 15 times 2 squared plus 12 times 2 minus 8. And if you put that in a calculator and press equal, you're going to get minus 12. So 2 minus 12 is the next turning point. All right, so I've identified our turning points. So the next thing we need to do is that we need to classify these turning points to say if they're maximum or minimum. Now, to do that, we're going to do the second derivative test. So we have dy by dx is equal to 12x squared minus 30x plus 12, and d2y by dx squared is equal to 24x minus 30. All right, so next I'm going to say when x is equal to a half, so 24 times a half times 12, 12 minus 30, so d2y by dx squared would be 12 minus 30, which is minus 18, so it's going to be less than 0. If it's less than 0, it means that the graph concaves down, and if it concaves down, it means that the point, which is what, a half, the point which is a half minus 21 over 4 is a maximum turning point. All right, so next I'm going to say when x is equal to 2, I'm going to get 24 times 2, which is 48. 48 minus 12 minus 30 is positive 18. So d2y by dx squared, which is positive 18, is going to be greater than 0, means that it's positive. So it means that if d2y by dx squared is positive, the graph concaves up. If it concaves up at the point 2 minus 12, point 2 minus 12 would be a minimum turning point. All right, so I have a maximum, I have a minimum turning point. Let's see if we can find maybe a point of inflection. Now, at the point of inflection, I think d2y by dx squared is equal to 0. So d2y by dx squared, which is 24x minus 30, would be equal to 0. So 24x would be equal to 30. Divide both sides by 24. So x would be equal to 6 into both of them, you get 5 over 4. All right. So when x is equal to 5 over 4, y would be equal to 4 times 5 over 4 cubed minus 15 times 5 over 4 square plus 12 times 5 over 4 minus 8. And if you just put that in a calculator and press equal, you're going to get y is equal to minus 69 . minus 69 over 8. So the point 5 over 4 minus 69, 8 is a point on the curve, which may or may not be a point of inflection. To determine if it's a point of inflection, we can check the concavity before the point and after the point. So I think we have some information on that already. I could say when x is equal to 1. So this is before the point. d2y by dx squared would be equal to 24 times 1 minus 30. All right, so this is going to be what? Less than 0, means that it's negative. If it's negative, it's concaving down. When x is equal to 2, d2y by dx squared would be 24 times 2 minus 30, which means that this would be what? Greater than 0. So it means if it's greater than 0, it means that after the point it's concaving up. So therefore, since before the point and after the point, 5 over 4 minus 69 over 8, the curve changes concavity. It means therefore that what? 5 over 4 minus 69 over 8 is a point of inflection. All right, so I think we have enough information now to sketch our curve. So this is the information we have. 0 minus 8, which is here, is the y-intercept. A half minus 5 1/4 is a maximum turning point. So a half, this is 5 1/4 would probably put me somewhere, let's just say about here. That's a maximum turning point. 1 point, we have 2 minus 12 is a minimum turning point. 2 minus 12 would put me here. 2 minus 12 is a minimum turning point. 1.3, this is 1, 1.5, 1.3, 8.6. Let's say that puts me about there. That is my point of inflection. All right, so essentially we have enough information now to draw a graph. All right, that's that half of the graph. Over here, go through my point of inflection, turn at the minimum turning point, and just let's go back straight up. All right, so let's do our best. Go back up until the graph cuts the y-axis. So this would be the graph of y is equal to 4x cubed minus 15x squared plus 12x minus 8. All right, and you can just have a good look at it. We have the y-intercept, the maximum and minimum point, and the point of inflection. And so this is what we were asked to do.